Okay, so this is problem 30 out of section 4.1, or 4.3, I mean. We have x double prime plus 4x prime plus 8x equals e to the negative t. There's a minus sign in there. My minus and my bar kind of went together. That really is a negative t. Thank you, Nick.
Thank you.
Or Marcus. Okay, so again, what I like to do here, the Laplace transform of x double prime. That's s squared capital X minus s x at 0 minus x prime at 0. And the Laplace transform of just regular old x prime was s capital X minus x at 0. So I just kind of like to write those down so I remember them. Of course, when you go to take your test, you're probably going to have those written on your formula sheet. So I won't necessarily expect you to write them down on your test. You would just go ahead and plug the values right in. I could give it to you on your test. I don't plan on giving it to you on your test. Seeing as you have a note card, you can have it all there all by yourself.
Can you write stuff on the formula sheet?
How about the back of the sheet? Can you write stuff on my formula sheet? Well, we haven't decided yet if you're going to use my formula sheet or if you want to write up your own note card.
I thought you said you were going to give us the choice. Like, you could either bring a note card or...
Oh, no, it's the whole class. We'll have a vote and there'll be arm wrestling and stuff. It'll be exciting. Alright, so for this problem, plugging in, I'm going to have s squared capital X. Because this is 0 and that's 0. That's kind of nice. Then I'm going to have a plus 4s capital S, because that's 0, but I did have to multiply by that 4 right there, plus 8 capital X equals, what's the Laplace transform of e to the negative t?
Isn't that like something over s minus a, something over s minus a?
1 over s minus a, and in this case a is negative 1, so that's 1 over s plus 1. All right, well, our next step would be to get all the capital X things on one side, all the things without capital X on the other. We already have that.
Yeah.
That's nice.
We factor it out, right?
We factored it out. Why did that happen? How come all the capital X's are on one side and all the non-capital X's are already on the other? Because both of our initial conditions were 0. If both of those initial conditions are 0, that's always going to happen because these three other things are going to go away. So that makes this problem a little easier. That's nice. Okay, so we factor. We're going to have s squared plus 4s plus 8 capital X equals 1 over s plus 1. And then we divide.
Well, wouldn't it be a good idea to factor the quadratic first and then divide both of them? That way you don't have to do it on the other side?
Well, I've got to divide at some point. I can factor now and divide, or I can divide and factor later. I don't see where there's much change in the amount of work. The bad news is, and it's worse than that, the bad news is s squared plus 4s plus 8 doesn't factor.
It does.
It does if you use imaginary numbers, that's correct. But when I say factor, I mean factor over the reals. Everything factors over the complex numbers. We're only dealing with the real world most of the time in this class. So x of s is 1 over s squared plus 4s plus 8 times s plus 1. Well, what we need to do a couple things. I think we need to first take this and do partial fractions, the way it's written. And then, once we do partial fractions, we're going to have to take this s squared plus 4s plus 8 part. It doesn't factor. What do you do with things that don't factor? Cross them out? No. You don't cross them out. We have to complete the square. We'll have to complete the square on that piece. All right, so I'm going to leave some room there. little x, eventually that'll be my answer. But what I need to do now is I need to take 1 over s squared plus 4s plus 8 times s plus 1 equals, I'm going to have an s squared plus 4s plus 8 on bottom of one of my fractions and an s plus 1 on the bottom of my other. What has to go on the top of my fractions?
A squared plus bs, c.
The first one needs an as plus b because that's a quadratic on bottom, which doesn't factor. And the second one just needs a c because that's linear down on bottom.
You're not going to complete the square first, and then do partial fractions.
No, I'm going to do partial fractions first because it's more complicated if I complete the square. The thing on bottom now looks stranger. I think it'd be a little. You'd get the same answer, but I think it's easier to leave it in this form and complete and do the partial fractions complete later. Okay, 1 equals as plus b times s plus 1 plus c times s squared plus 4s plus 8. Anybody have a favorite number?
-1.
-1. S equals -1. When I plug in s equals -1, I get 1 equals. I get a 0 right there, so the a and the b are both eliminated. And I get 1 minus 4 plus 8. That sounds like about 5. 5c. Around 5. So c is 1/5. Okay, how am I going to find a and b? Yeah, I've got a choice here. One choice would be to figure out what numbers give you 0 here.
Then you don't see as 1/5. Can you just plug in 0? And then that'll get b by itself.
Oh, that's an excellent idea. Yeah, I see what Liam's saying. If I plug in s equals 0, that's going to get rid of the a. We already know c is 1/5, so the only letter remaining will be the letter b. Oh, good trick. All right, so 0, when I plug in 0, I get 1 equals b times 1, that's b, plus, when I plug in 0, I get 8 there, so 8/5, which says b is -3/5.
Wait, I'm sorry, where did this come from again?
Where did the 8/5 come from? I plugged in 0, which gave me 0 plus 0 plus 8, that was 8. And then I plugged in 1/5 for c. 1/5 times 8 is 8/5.
Oh, I mean.
All right, and now I think I can plug in any other number in the world that I like 1.
Wait, you already put in
No, I plugged in -1. When I plug in 1, I get 1 equals a minus 3/5, because b is minus 3/5, times 2, plus 1/5 times 8 and 4 and 1 is 13. Okay, so then I have to solve for a. That's going to be 2a minus 6/5 plus 13/5, so that's 2a plus 7/5. Subtract 7/5, 1 minus 7/5 is minus 2/5 equals 2a. So a is minus 1/5. Good? Okay, so we did the partial fractions now. Now what we need to do is deal with this right here. We know that we have minus 1/5 s plus negative 3/5 divided by s squared plus 4s plus 8. Now what I need to do is I need to complete the square on this one and get that into a form where I can find an inverse Laplace transform. That's going to be s squared plus 4s plus, what's the magic number to add to complete the square? 4, because you take 4, you divide it by 2, you square it, that's 4. Plus 8 minus 4. And I still have 1/5, minus 1/5 s, minus 3/5 up on top. Minus 1/5 s, minus 3/5 divided by s plus 2 squared plus 4.
Where's mine?
Looking at my big chart of Laplace transforms. What am I headed for here? I'm looking at these two bottom ones, aren't I? Because I have an s minus a squared plus k squared. So notice if I have an s minus a here, to match the cosine, I need to have an s minus a on top. So if I have an s plus 2 here, I need to have s plus 2 there. Okay? Say that again. I thought somebody just said something profound.
I think Jesse said it.
I'm trying to catch up to you.
Oh. I thought somebody said we already have an s plus 2 up there.
We already have an S plus 2.
Yeah, we do.
We do? Where is it?
Oh.
It's hidden. Yeah, I don't think we have one up there. It's unfortunately very, very close. If I were to factor out the negative 1/5, I would have a s plus 3. It's tantalizingly close, but it's not correct, is it? That's unfortunate. Okay, but I think I'm going to do that anyway. I'm going to factor out the negative 1/5 and then write this as s plus 3 over s plus 2 squared plus 4.
You have to split it up.
I'm not going to square it all, no.
No, split it up and then use plus 2 and then compensate minus 2.
That's exactly what I'm going to do. What I'm going to do is I'm going to change this to be an x plus 2 and then compensate by doing a... All right, so I'm going to change this.
Well, where did the
Go ahead. Where did the what come from? X?
Oh, just kidding, we're good. Did you say X or
You
S?
keep saying, it's not like you're
Yeah.
saying X, but you're saying S.
S. I will try to enunciate better. All right. Maybe I was saying X. I don't
I
know.
think you were.
I think it's okay.
It's possible. I quite often write one thing and say another. Okay, so I'm going to write negative 1/5. I'm going to call that s plus 2. S plus 2. S plus 2 squared plus 4. Now, what did I do? To go from an s plus 3 to an s plus 2, I subtracted 1. So I also need to add a 1. But, yeah, you guys are catching on here. When I subtracted that 1, it was really inside this parenthesis. So by doing a minus 1 in here, I really did a minus 1 times a minus 1/5. So I really added 1/5, which means outside, to balance that out, I need to subtract a 1/5. And that's a very easy place to make a mistake. It's very easy to say, I'm doing a minus 1 here, so I'm going to do a plus 1 there.
I was really confused. Why didn't you do it the old way?
Yeah, I factored this 1/5 out.
No, but split those two.
So you're absolutely right. Now I'm going to split these two.
No, but why didn't you do another part? Where's negative 1/5? And that's minus 3 fifths. No.
I could have split it out earlier. I could have written this as minus. I could have written this as minus 1/5 divided by this, and then minus 3/5 divided by that. I could have split it out earlier.
And then compensate. Subtract 2.
Uh huh.
No, it's add 2 for the first part when you split it up. And compensate. Minus 2.
But you would need to be careful. What Greg is saying is, well, let's finish it first, and then I'll come back to that. You got to be careful. You're still missing a 1/5 also. Okay, so we're getting very, very close. We're going to have a negative 1/5 s plus 2 over s plus 2 squared plus 4. That finally fits exactly into our cosine with an e to the at form, yes?
Why is that 1/5 negative again? Because didn't you multiply it by a negative?
Okay, so inside my parentheses, to go from an s plus 2 to an s minus 2, what did I have to do? Subtract 1, but I did it inside the parentheses. When I do something inside this parentheses, it's also being multiplied by this negative 1/5. So a negative 1/5 times a negative 1 is a positive 1/5. So on the top, I really put a positive 1/5. If I put a positive 1/5, I have to balance it with a negative 1/5.
So where did the negative 1/5 go in that last step that you had?
Right there.
No, the next step after that.
Oh, I wasn't done.
Oh, okay.
Minus 1/5.
Okay.
S plus 2 squared plus 4. I wasn't done writing yet. This first one fits into our cosine form with the e to the at. With a negative 1/5 in front of it, right? What about this one? It almost fits into the sine form. Absolutely, I could. But looking at the sine form, if I have a k squared down on bottom, I need a k up on top. So that tells me I need to put a 2 up there, don't I? What's the penalty of putting a 2 up there? I have to balance it with a 1/2. So it's a big balancing act with these problems.
You need to be a 2 altogether. You want to multiply by that.
Well, I'm going to take this 1/5 and I'm just going to pull it out front.
Same thing.
So in essence, it's the same thing. I'm going to have 1/5 times 1/2, which is going to give me a 1/10. Right. Same thing. Okay, so now we're ready to write our final answer. What's the inverse Laplace transform of this piece? Negative 1/5. E to the at, where a is negative 2t, cosine of 2t because of this 4. That's 2 squared. 2t. Minus the inverse Laplace transform of this part. I'm going to put the 1/5 and the 1/2 together. That's a 1/10. And then I have 2 over s plus 2 squared plus 4. That's e to the negative 2t sine 2t. And then, don't forget, we still had that little piece too that didn't have that completing the square portion. I need to take the inverse Laplace transform of that also. C was 1/5. E to the negative 1t, that is correct.
Yes. That's what I was talking about earlier. I started working on that first.
You should have worked on that part first.
What?
Okay, so now let's go back to Greg's question. Okay, so here was Greg's question. When I had this back on the previous page, I went ahead and I factored out the negative 1/5. Greg's question was, can't you split it right away? And my answer is yes. You can write this as negative 1/5 s over s plus 2 squared plus 4 minus 3/5 over s plus 2 squared plus 4. Absolutely you can. Then what? So if I compensate, I have to do a plus 2. Like that?
Yeah. Minus 2. Yeah.
No. This s is being multiplied by negative 1/5.
You can pull it out, right?
I can pull it out, but it's still being multiplied by that, isn't it? Even if I pull it out, I still really have a set of parentheses around that. So if I put a plus 2 there, I didn't just simply add 2. I really did a plus 2 times negative 2/5. So I did a negative 2/5, which means to compensate over here, I would have to add a 2/5. But then I need to be careful because that's got a minus sign in front of it, so I better write it that way to make sure I make all my numbers line up correctly. So even if you split them early and do the plus 2, that plus 2 is still hit by that negative 1/5. You still need to balance with the proper number over there.
Can you solve it like that, or?
Absolutely, I can.
You also saw a whole bunch of less than.
Because this one now works perfectly. This one fits into the cosine. This one, I would have to combine these numbers. Notice that I have a negative 1/5, but then I would have to say, oops, I really got to have a 2 on top, not a negative 1/5. So I'd have to do exactly the same thing. I'd have to multiply by a 2 and divide by a 2. And I would get exactly the same answer.
That's right.
Questions?
All right. Have a wonderful break, George. Not a question.